Out in the cold expanse of our solar system, Saturn hangs as a world of breathtaking beauty. Its pale golden glow has fascinated skywatchers for centuries, a distant beacon shining through the darkness of space. This is Saturn, a colossal ball of hydrogen and helium, spinning nearly 1 billion miles from the Sun. Its immense size and swirling clouds make it one of the most captivating planets in our solar system, a true giant among worlds. Even a small telescope reveals its most iconic feature, the rings, a shimmering halo of ice and rock, encircling the planet like a celestial crown. These rings stretch out for hundreds of thousands of miles, yet are astonishingly thin, sometimes only a few dozen feet thick. Saturn is vast. Over 760 Earths could fit inside it, yet it's so light it would float in water. Its low density is a reminder of its gaseous nature, and its sheer scale dwarfs anything we know on Earth. Its butterscotch bands are clouds of ammonia ice, whipped by winds over 1,000 miles per hour. These powerful storms and jet streams create mesmerizing patterns, painting Saturn's atmosphere with ever-changing stripes and swirls. For most of history, Saturn was just a wandering star in the night sky. The telescope changed everything, opening a new era of discovery and wonder. Galileo first glimpsed its strange shape, puzzled by what he saw. But it was Christian Huygens who realized Saturn was surrounded by a thin, flat ring, forever altering our view of the planet and the possibilities of the cosmos. This discovery transformed our understanding of the cosmos, revealing that planets could have features stranger than we'd ever imagined. Saturn's rings became a symbol of the mysteries waiting to be uncovered in the universe. Saturn's name comes from the Roman god of agriculture and wealth, a fitting title for a planet that has enriched our knowledge of the universe. Its mythological roots remind us of humanity's long fascination with the heavens. To the ancients, Saturn marked the edge of the known world, the last planet visible to the naked eye. It was a boundary between the familiar and the unknown, a gateway to the mysteries beyond. Today, it's a destination, a place of deep mystery, holding secrets about how planets form and evolve. Robotic explorers like Cassini have revealed Saturn's wonders, but many questions remain. Saturn's rings set it apart, making it a symbol of the unknown frontier. Their origin and fate are still debated, challenging scientists to unlock their secrets. In the modern age, Saturn is not an end, but a beginning. Each mission to this distant world opens new chapters in our quest to understand the solar system. It beckons us to explore, to seek answers about the origins of worlds and the possibilities of life. Saturn's moons, too, may hold clues to life's potential beyond Earth. The journey to Saturn is a journey into the heart of cosmic wonder, a voyage that continues to inspire, challenge, and expand our imagination. To truly know Saturn, we had to go there. The Cassini-Huygens mission, a collaboration between NASA, ESA, and the Italian Space Agency, launched in 1997, embarking on a 7-year journey to Saturn. Cassini orbited Saturn for 13 years, revealing the planet, its rings, and its moons in unprecedented detail. The Huygens probe made history by landing on Titan, sending back the first images from the surface of a moon in the outer solar system. Cassini's grand finale saw it dive between Saturn and its rings, before plunging into the planet's atmosphere in 2017. Its mission ended, but the data it returned will fuel discoveries for decades. Cassini transformed Saturn from a distant mystery into a world we could almost touch. Among Cassini's discoveries, one stands out, the Great Hexagon, a gigantic 6-sided storm at Saturn's North Pole. This isn't a solid structure, but a jet stream forming a near-perfect hexagon, each side wider than Earth. First glimpsed by Voyager, Cassini revealed its dynamic, multi-layered nature and a massive vortex at its center. The hexagon's shape is a puzzle. Scientists have recreated similar patterns in labs, but the exact conditions on Saturn remain mysterious. As Saturn's seasons changed, Cassini watched the hexagon shift from blue to gold, revealing chemical changes triggered by sunlight. The hexagon is a living weather system, a geometric marvel in the clouds. Its depth, origin, and uniqueness remain unsolved mysteries. Even with all Cassini taught us, the hexagon is a reminder that Saturn still holds secrets. It's a cosmic enigma, waiting for future explorers. Saturn's magnetic field is unlike any other in the solar system, presenting a puzzle that has baffled scientists for decades. On Earth and Jupiter, the magnetic axis is noticeably tilted compared to the planet's rotation, but Cassini found Saturn's is almost perfectly aligned. less than 0.007 degrees off, an astonishing level of precision. This remarkable symmetry defies our current understanding of planetary dynamos, which require a tilt to sustain a magnetic field over time. Without a tilt, the dynamo theory struggles to explain how Saturn's field even exists. The near-perfect alignment also makes it nearly impossible to measure Saturn's true day, since the magnetic field doesn't wobble or drift as it does on other planets. Cassini tried to solve this mystery by tracking the movement of clouds and subtle waves in Saturn's rings, hoping to find clues about the planet's rotation, but uncertainty remains. Some theories suggest a shallow dynamo or hidden layers deep inside Saturn, perhaps involving exotic forms of hydrogen, but the truth continues to elude us. Saturn's magnetic field is a fundamental mystery, challenging our models of how planets work and forcing us to rethink what we know about planetary interiors. It hides the planet's true rotation and hints at unknown processes taking place deep within Saturn's vast, swirling interior. To truly understand Saturn, we must first solve the riddle of its magnetic heart, a challenge that continues to inspire planetary scientists. Cassini's findings have sent scientists back to the drawing board, sparking new theories and debates about what lies beneath Saturn's clouds. Saturn's core remains one of the solar system's great enigmas, a secret waiting to be uncovered by future explorers and missions. Enceladus, once overlooked, became a star thanks to Cassini. In 2005, Cassini spotted plumes of water vapor and ice erupting from cracks near Enceladus's south pole. These tiger stripes vent material from a global ocean beneath the ice, creating Saturn's E-ring. Cassini flew through the plumes, detecting salt, silica, and complex organic molecules, the building blocks of life. The evidence points to hydrothermal vents on the ocean floor, similar to those on Earth that teem with life. Enceladus's ice shell floats on a warm, salty ocean that covers the entire moon. This makes Enceladus one of the most promising places to search for life beyond Earth. Cassini couldn't detect life, but it showed us where to look. Enceladus has redefined our search for habitable worlds, moving the goalposts to the icy moons of the outer solar system. It's a beacon of possibility in the cosmic dark. Titan, Saturn's largest moon, is a world both familiar and alien. Orbiting far from the warmth of the sun, it stands out as one of the most intriguing places in our solar system. It's the only moon with a thick atmosphere, denser than Earth's, shrouded in orange haze. This dense blanket of nitrogen and methane gives Titan its mysterious golden glow, hiding its surface from view. Cassini and Huygens revealed a landscape shaped by methane, rivers, lakes, and seas of liquid methane and ethane. These alien rivers carve valleys and channels, creating a world that eerily echoes Earth's own water-shaped terrain. Titan's surface features mountains of water ice and vast plains of organic sand. Winds sculpt massive dunes, while icy peaks rise above the frozen landscape, forming a terrain both beautiful and bizarre. The Huygens probe landed in a riverbed of icy pebbles, offering a human-scale glimpse of this strange world. For a brief moment, we saw Titan's surface up close, cold, alien, yet strangely reminiscent of riverbeds on Earth. Titan's methane cycle mirrors Earth's water cycle, with rain, rivers, and seas. Methane clouds gather and pour rain onto the surface, feeding rivers that flow into vast, dark seas. Its surface is covered in complex organic compounds, hinting at prebiotic chemistry. These rich organic materials may hold clues to the building blocks of life, preserved in Titan's frigid environment. Models suggest a hidden ocean of liquid water beneath the ice, making Titan a world with two potential habitats for life, one in its organic-rich surface and another in its subsurface ocean. Cassini mapped Titan, but its mysteries remain. What lies beneath its seas, and could life exist in its alien chemistry? The answers may change our understanding of life in the universe. Titan is a natural laboratory for understanding the chemistry that might precede life. Scientists study its atmosphere and surface, searching for clues to how life could begin elsewhere. The exploration of this parallel Earth has only just begun. With every mission, Titan draws us closer, inviting us to uncover its secrets and imagine what might be possible on worlds so different, yet so strangely familiar. Saturn's rings, long thought ancient, are surprisingly young. Cassini's data suggests they may be just 10 to 100 million years old, formed when dinosaurs roamed Earth. The rings could be the remains of a shattered moon or comet, torn apart by Saturn's gravity. They're made of over 98% pure water ice, supporting the idea of a destroyed icy body. Cassini saw dynamic structures, propellers, vertical waves, and moonlets within the rings. The rings are raining onto Saturn and may vanish in 100 to 300 million years. We live in a rare era, witnessing Saturn at its most beautiful. The rings are not eternal but fleeting, a cosmic spectacle in our time. Their origin and fate remain open questions. Saturn's rings remind us that even the grandest features can be temporary. Cassini answered many questions but left even more. Is there life in Enceladus's ocean? We need new missions to sample its plumes or explore beneath the ice. The true age and origin of the rings remain uncertain. What event created them and how do they evolve? Saturn's magnetic field and hidden rotation challenge our understanding of planetary interiors. Titan's lakes, dunes, and chemistry are only partially explored. Future missions like the Dragonfly drone could reveal more. Saturn's atmosphere itself is still a mystery, waiting for a probe to dive deep and measure its secrets. Each answer uncovers deeper mysteries, fueling the next generation of exploration. Saturn is a book with many chapters yet to be written. Saturn is more than a planet. It's a miniature solar system, rich with worlds and mysteries. Cassini's discoveries changed our view of where life might exist, showing that even icy moons can harbor oceans and organic chemistry. The search for life is no longer just about finding another Earth, but about exploring new possibilities. Like Enceladus and Titan, missions are being planned, probes to Saturn's atmosphere, orbiters for Enceladus, drones for Titan. Each mission builds on the last, pushing the boundaries of knowledge. Saturn's secrets challenge us to keep exploring, to seek answers about our place in the cosmos. The journey continues, and with it, our understanding of the universe and ourselves deepens. The call of Saturn is the call of the unknown, and we must answer.